Okay, great. Here we go, guys. All right, so again, without writing this down, let's start talking about what is a function. And you might know a little bit about it already. Yesterday we talked about a function being kind of like a machine where inputs go in, right? Some math happens, and then an output comes out. We also talked about independent variables going in, dependent variables coming out. And we talked about domain being all of the x variables and range being all the y's. There are really three ways of describing data, whether they're a function or not. A table, right? With inputs and outputs. You can also use a graph, right? Like we have a graph here with x and y's and various points. You can also use a formula, right? An equation that relates to two variables. There are other ways too, which we will discuss later. But those are the three main ways. Here, the graph is, instead of just a bunch of points, they can sometimes be connected to form a curve. Sometimes that curve is a straight line, sometimes it's not. There are lots of different types of things that can be functions. All right? Okay, so here's the really important piece. All three of these ways of showing a function meet the definition of a function, which is this. Given the value of an independent variable, in this case, in your table, the values of t, right? The value of the dependent variable, in this case s, is determined. There's only one value of s for each value of t. It's a really tricky thing to understand, but that's what a function is. There's only one output value for each input value. And that's shown by this table, it's shown by the graph, and it's shown by the formula. What do we mean by that? Well, the independent variable, often defined as x, can only result in a single dependent variable, often denoted as y. So we'll say something like s is a function of t. What that means is that the t value determines the s value uniquely. Okay? A way to think about this is a soda machine. If you go up to a soda machine and let's say there's a button for regular cola, and then there's a different button for Diet Cola. There can be several buttons for regular cola. Let's say this whole top row is regular cola, and let's say this whole second row is Diet Cola. If you press a button for regular cola, you get a regular cola out. You press this first button, you get a regular one, right? You can also press this second one, it's a different button, and you still get regular cola out. That's a function. When you press the Diet Cola buttons, no matter which one you push, you get a Diet Cola out. There's no button that you push, and sometimes it's a regular cola and sometimes it's a Diet Cola. That would be not a function, right? If you press the same button every time and you're getting different outputs, there's no math that does that, right? There's no function where that actually works. So that would not be a function. If you're putting the same input in over and over again and you're getting different outputs, that would be not a function. This is a tricky thing for us to express again, okay? So a couple of examples, and we will write these down in our notebooks in a minute, similar practice problems. So two of these tables are functions, and one of them is not. This one is a function. The first one's a function because x, our inputs, each give us one output, right? Negative 11 produces a 3. Negative 5 produces a 4. Great, etc. This one's also a function. Each x value produces a unique y value. Now, look at this. If you have an input of 1 for x, you get an output of 2 for y. There's another input that also gives you an output of 2 for y. What is it? It's 6. Yes, 6 also gives you a 2 for y, but that's allowed. It's okay to have two different inputs that both give you the same output. That's still a function. That's just like having two differently placed cola buttons that both give you a regular cola. Right? This one is not a function like the last one. Why is it not a function? Because what happens when I press the negative 1 button? Does it always give me the same output? No. What are the two different outputs for an input of negative 1 here? Yeah, Marie. 5 and 9. That's like I press the Diet Cola button and sometimes I get a Diet Cola button and sometimes I get a regular. That would not be a function. Okay? On a graph, we can determine if something is a function by doing something called the vertical line test. So, if you put a vertical line anywhere on your graph, if your graph has, say, this V-shaped two lines on it, and you're trying to figure out if it's a function. If you're able to draw a vertical line, and you can sometimes just use a pencil or a marker for that, anywhere on this graph, if it touches more than one point on your curve, then it's not a function, right? Basically what this is saying is a vertical line touching a graph two or more times would say there are two outputs for the same input, right? There are two y values for the same x value, and it would not be a function. Okay, so what do you think? Raise your hand if you think you know for this V-shaped graph, the first one, does it pass the vertical line test? In other words, is there always just one point where a vertical line is touching this V? If you said yes, you're right. I'm not going to tell you the answer to the second one, but think to yourself, does it pass the vertical line test, or does a vertical line intersect this one twice? Answers, a function. This one passed, right? Not a function. This one did not pass. So at this x value, it didn't pass because there are two y values associated with that x value. If you put in an x input of 2, you get two different outputs. It's not a function. Okay, you can draw the graph of it certainly, but it's not a function. Okay. This is another example of the vertical line test. This first one is a function, right? Because the vertical line can't be placed anywhere in the graph since it touches it in two places. So it works. Each input has one output, right? For the second one, sorry, it fails the vertical line test because there are inputs that have two outputs, and that's shown by the vertical line touching the curve two or more times. All right? Let's try this. I would like you on graph paper to draw these two functions, okay? And if you need graph paper, get some from me if you have it in your notebook. This is 3.1 continued. And after you draw them, try to think about which one is a function, if any.